Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Younger Dryas energy calculations. This video estimates the energy of the secondary impacts of glacier ice that formed the Carolina Bays and shows how the saturation bombardment that created the bays was responsible for the extinction of the megafauna from the Rocky Mountains to the east coast of the United States. The megafauna included mastodons, which were larger than today's elephants and had a shoulder height of about 3 meters or 10 feet. Wikipedia offers a perspective of the current thinking about the extinction of the megafauna. Quote, Pleistocene megafauna is the set of large animals that lived on Earth during the Pleistocene epoch and became extinct during the Quaternary extinction event. Megafauna are any animals with an adult body weight of over 44 kilograms or 97 pounds. 4 theories have been advanced as likely causes of these extinctions: hunting by the spreading humans, climatic change, spreading disease, and an impact from an asteroid or comet. These factors are not necessarily exclusive. 2 or more may have combined to cause the extinctions. Most evidence suggests that humans were a major factor responsible for these extinctions. End quote. Are we supposed to believe that Stone Age humans were a major factor responsible for the extinctions? And that with their spears and arrows they eliminated all the mastodons, camels, mammoths, short-faced bears, lions, dire wolves, and saber-toothed tigers? This is preposterous. Climate change is more believable because the Younger Dryas brought a sudden drop in temperature of 10 degrees Celsius, but this was a temperature that the megafauna had survived earlier during the Ice Age. The spreading of disease is purely hypothetical, since it is not likely that so many different species could have succumbed to a plague so suddenly over such a large territory. The impact from an asteroid or comet is listed last because it is considered to be the least likely cause of the extinctions, and many scientists suppose the idea that an impact actually occurred. But this is what we will examine today. To understand extraterrestrial impacts, it is necessary to understand crater formation. When the Limited Test Ban Treaty came into effect in 1963, it prohibited nuclear testing in the atmosphere, so the military agencies turned to alternative methods of generating air blast effects with high explosives. One of these experiments was called Operation Sailor Hat, that was carried out in the small island of Kaho'olaui in the Hawaiian archipelago. This image shows the decommissioned ship USS Atlanta anchored close to a pile of half a kiloton of chemical explosives. A worker and a fire extinguisher provide a sense of scale. The detonation resembled a small nuclear explosion, creating a shock wave on the water and an expanding shock condensation cloud. The fireball and mushroom cloud were present but without radiation or radioactive fallout. The blast created an overpressure of 10 pounds per square inch on the target and a moving wall of highly compressed air with a maximum wind speed of 294 miles per hour. An overpressure blast of that magnitude is equivalent to a burst of 1 megaton of TNT and is sufficient to be lethal and capable of destroying reinforced concrete buildings. The explosion of Operation Sailor Hat made a crater that still exists today and has the uplifted rims that are typical of explosions and impact cratering. Experiments like this enable scientists to derive equations that relate explosive energy to crater size. In 1989, Professor J. Melosh published the book Impact Cratering, a Geologic Process. The book contained formulas relating impact energy to crater size. Professor Melosh's formulas were adapted by Ross Bayer for an online program that computes projectile size from crater diameter. The calculator takes into consideration the velocity of the projectile, its density, the impact angle, and the target characteristics. This calculator can be adapted for use on the Carolina Bays. The origin of the Carolina Bays was contested for more than 80 years. Some scientists proposed that wind and water created the bays, while others proposed an impact origin. The 2017 publication of the Glacier Ice Impact Hypothesis described 4 mechanisms that explain the formation of the Carolina Bays. First, a meteorite impact on the Laurentide ice sheet ejected ice boulders in ballistic trajectories. The secondary impacts by the ice boulders liquefied on consolidated ground close to the water table. Oblique impacts of ice boulders on the liquefied ground created inclined conical cavities. And finally, Viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. The elliptical geomorphology of the Carolina bays, their raised rims, and their radial orientation toward the common point by the Great Lakes are the major features that identify the bays as impact structures and differentiate them from structures created by terrestrial processes. The top inset shows an inclined cone with an elliptical conic section. The bottom inset shows an experimental inclined conical cavity produced by the impact of an ice projectile. The conical cavity is elliptical when viewed from above. The raised rims are overturned flaps created by the compressing plowing action of the ice projectile. The LiDAR images of the Carolina bays make it easy to verify the elliptical geomorphology of the bays. From the width-to-length ratio, we can calculate that this particular bay corresponds to a cone inclined at 30 degrees, which would also correspond to the launch angle of the ice boulder that made the bay. The bay is 1,080 kilometers from Saginaw Bay, which is the origin of the ice projectile. Saginaw Bay was calculated as the convergence point of the bays by Michael Davias in 2010. Using ballistic equations, we obtain a launch speed of 3,498 meters per second and a loft time of 356 seconds, or 5.94 minutes. It is difficult to visualize the sizes of the Carolina bays because some of them are so big. This particular bay has a length of 4,160 meters, which corresponds to the distance between the Lincoln Memorial and the U.S. Capitol in Washington, D.C. At this scale, a mastodon would be an insignificant dot in the image. The program to calculate projectile size from crater diameter assumes that the crater is circular. By equating the area of a circle to the area of an ellipse, we find that the equivalent radius of the ellipse is the square root of the product of its semi-major and semi-minor axis. The diameter of the ellipse can then be used to calculate the projectile size. The program calculates that the ice projectile that formed the large bay had a diameter of 1,180 meters and energy of 1,250 megatons. The Wikipedia page about nuclear weapon yield says that as of 1996, all nuclear testing by all nations was 510,300 kilotons of TNT. That is only 40% of the energy of this single impact. The most powerful nuclear weapon ever detonated by the Soviet Union in 1961, called the Tsar Bomba, had a yield of 50 megatons, which is puny compared to the energy that created this Carolina Bay. A projectile diameter of 1,180 meters is an ice chunk bigger than 1 kilometer. The impacts that created the Carolina Bays had so much energy that they would have killed any animals or humans nearby. This is why the creation of the Carolina Bays has to be associated with an extinction event like the extinction of the North American megafauna and the Clovis people. It would have been impossible to survive the saturation bombardment by this powerful and horrific hailstorm. This example gives us a glimpse of the immense power of the extraterrestrial impact and the ballistic sedimentation of the ejecta curtain consisting of glacier ice boulders. We are now going to look at a smaller bay that was in place later in time. When the comet or asteroid impacted the Laurentide ice sheet, it took 30 seconds to excavate a 44-kilometer crater in the ice sheet. During these 30 seconds, ice boulders were ejected at different angles and at different speeds. This smaller bay was emplaced after the large bay because it overlaps its rim, and the geologic principle of superposition tells us that newer structures overlay older structures. The ballistic equations tell us that most of the secondary impacts on the East Coast occurred between 6 to 9 minutes after the extraterrestrial impact. The equations also make it possible to determine the relative time of emplacement. This bay has well-defined margins, a width of 688 meters and a length of 1,086 meters. The width-to-length ratio corresponds to an impact angle of 39.3 degrees. The projectile that made the bay had a higher trajectory and longer flight time, so it landed on the rim of a previously formed bay. Its loft time was 424 seconds, or 7.06 minutes, which is 1 minute more than the large bay that we examined earlier. The difference in flight times makes it possible for ice projectiles with higher trajectories to produce impact scars on bays created earlier by projectiles with lower trajectories. Using the same calculations as before, the projectile that made this bay had a diameter of 252 meters. The energy released by the impact was 10.7 megatons. Let us now zoom out and take a broader look at the landscape. The arrows show the two bays that we just analyzed in detail. This LiDAR image shows the Carolina Bays 25 kilometers southwest from Fayetteville, North Carolina. The image covers an area of about 550 square kilometers. The 5-kilometer scale at the bottom of the image indicates that the Carolina Bays vary from a few hundred meters to several kilometers in size. This is the central part of the previous image. It is completely saturated with Carolina Bays. The larger bays with major axes from 1.8 to 2.1 kilometers were formed by impacts of 62 to 116 megatons. The small bays with major axes from 700 to 900 meters had an energy of formation from 2.5 to 5.4 megatons of TNT. The tiny bays that looked like little dimples of about 100 meters were made by impacts with energy of 10 to 15 kilotons, which is similar to the bomb dropped on Hiroshima, with a yield of about 15 kilotons. It is important to point out that the river channels disappeared during the ice bombardment and were carved out later by the meltwater of the ice boulders and subsequent rains. It is important to ask two questions. Where could you have hidden, and how could you have survived? The answer is that there was no place to hide and there was no way to avoid death. The icy ejecta curtain had a radius of approximately 1,500 kilometers, and all the fauna were doomed within this circle. It may be impossible to find any recognizable remains of the megafauna after such energetic impacts. The outermost circle, with a radius of 1,500 kilometers, shows the extent of the kill zone covered by the ejecta curtain. The Carolina Bays and the Nebraska rainwater basins are within this circle. Canada was covered with the Laurentide ice sheet, so any ejecta north of the Great Lakes fell on the ice sheet. Impacts in the Mississippi River Basin did not produce bays because the ground is hard and the ice pieces just disintegrated explosively when they landed. From the energies that we have calculated, it is evident that the saturation bombardment that created the bays was responsible for the extinction of the megafauna all the way from the Rocky Mountains to the east coast of the United States. Animals outside this area could have survived, but the 1,200 years of cold weather that followed the impact made life very difficult. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.